Next, we've got Iratxe Menchaca. She's going to talk about characterization of biofouling and antifouling coatings in the marine environment. Thank you.
Thank you.
Green is
Okay, thank you. So thank you very much. Thank you for giving me the opportunity to present some of the results of the Equiocean project. Well, today I'm going to focus on the characterization and the biofouling, but well, the main goal of the Equiocean project is to carry out research into new suitable and innovative approaches, focus on the floating photovoltaic plants. We focus on the critical elements of this new, well, not new, but yes, the scenario is new in the marine environment. These critical elements is in regard to the environmental risks and the site identification tools for this kind of technology in the marine environment. We also focused on the flotation systems, and in this, for this particular case, today I'm going to talk about the characterization of the harmful effects of the sea in these floating photovoltaic plants. We published a guideline, including well, the recommendations and how to manage and how to monitor this kind of structures in the marine area. We collect different feedbacks from a survey, collecting the contacts from different stakeholders through the EMODnet platform. So I think, well, could be interesting for any kind of stakeholder in this technology. So, as I mentioned before, today I'm going to focus in a specific goal, and is to evaluate the potential effectiveness of different bio-based antifouling coating through the characterization of the macrofouling organisms. We know that it's also very important, the first step of this ecological succession, but well, today I'm not going to go into the details of the DNA methodology, but I'm going to focus in the macro biofouling organisms. So in AZTI we have previous experience. Here I show you the HARSLab. HARSLab is a floating offshore laboratory. It's designed and operated by Tecnalia in the Basque Country. It's located in the Bay of Biscay, just in front of the Basque Coast, and is located in the BIMEP. BIMEP is a testing area for wave and offshore wind devices. And this laboratory at the beginning was designed to characterize and to identify the corrosion and the antifouling testing. But during the last 2 years, we have a collaboration between Tecnalia and AZTI, and we are also using this HARSLab as operational and oceanographic meteorological station, and we are monitoring the underwater noise. We are monitoring the mammals and the ichthyofauna through different equipment located in the HARSLab. But focusing on the biofouling analysis in the HARSLab, we located we deployed from summer 2022 to summer 2023 different panels in the submerged area and also in the splash zone, just to characterize in the context of NEOMAT project how was the effectiveness of different materials and coatings. So with this expertise, in the context of the Equiocean project, we decided to locate different concrete panels provided by Tecnalia and coated by Polymat from the Basque Country with different bio-based coating. Completely, they were latex. And we decided to put the different panels in the Ocean Meteorological Station in the outside part of the Pasaia Harbor. Pasaia is very close to San Sebastian. And also we located very close to AZTI. We are here in Pasaia, in the inner area of the harbor. And we decided to deploy the panels in the splash zone, but also in the intertidal and in the subtidal zones. So after the deployment, Different monitors and different visits were taking place, and during 9 months, we visit the panels every three months, in October, in December, and in March, was it the last March, yes. And in each visit, different photographs were taken. And then in the last sampling, in the last visit, we removed in March of the panels, and we took them to the laboratory for the biofouling analysis. So, following the guide developed by myself and some colleagues in AZTI, we evaluate the biofouling information in those panels. Here I show you the quantification of biofouling from the different photographs using the ImageJ software, what is quite easy to use. And in the last sampling, as I mentioned before, we remove all the concrete panels, and we identify the biofouling, and after scrapping the panels, we calculate the biomass. So here I show you some of the, yes, thank you, some of the main results regarding the quantification of biofouling. Here in this graph, I show you the relative coverage of the biofouling. I didn't mention before, sorry, that we use different control panels without any treatment, and we use 4 different treatments with the bio-based coating. And here in this graph, you can see that there is a progressive increase in the surface coverage from September to March, particularly in the subtidal panels inside the harbor. And only, there was no significant differences among the control and the different treatments, only in the treatment in the latex number 3. This is important. We don't know anything about this is a blindy analysis. We don't know anything about the composition of the treatments. So in the treatment number 3, we can see here some significant differences comparing to the control. And as you can see here in this picture, in this photograph, in one of the replicates, after 9 months of exposure, you can appreciate here that there is still some treatment, some latex in the panel, and this panel avoid the growth of the barnacles in the panel, and you can see them in the adjacent surface of the panel. So we only found these differences in this specific treatment. Regarding the species richness, the number of species, here in this graph you can see the evolution of the number of species through the whole experiment. And again, we didn't found any differences among the control and the treatments, and except the treatment 1 and treatment 4 in the intertidal zone. There is a slight decrease in the richness, especially in March. This is the typical, the normal evolution of the biofouling, because this is in the winter season, so there are some species that they are not appear. And, but again, no treatment shows significant differences. However, the most interesting results in our study is regarding the biomass, the biofouling biomass. Because after the retreatment, in March, when we removed the panels and we calculate the biomass, we found that there were significant differences between the control and the different treatments for all the different treatments, but only in the subtidal zone of the inner harbor. But there were no differences in the coastal area, none in the intertidal and nor in the subtidal. So, as a conclusion, okay, there was no differences in the coverage and none in the species richness between the control and the various treatment. However, we can see, or we saw that maybe the lower biomass found in the inner part of the harbor could be in relation, this is our hypothesis, could be related to the higher treatment effectiveness, of course, and because of the lower hydrodynamics in this part of the harbor. And in contrast, the splash exposure and the higher hydrodynamics in the coastal zone could reduce the treatment effectiveness, and that's why resulting in higher biomass. So, well, this higher effectiveness observing the treatment in the harbor area could help to improve design and increase the durability of the treatments. So, thank you very much for your attention.